Alright, so I'm sure we've all seen some kind of meme post like this with like, you got the math problem and then the Wi-Fi password is the answer, just however many digits it wants to go to. And this is today's one because it actually has an integral in it, and integrals are my specialty basically. And this actually looks really ugly. However, when you actually look at it deeper, it's actually very, very nice. It simplifies very well. So the first thing you want to notice is that our bounds are from -2 to 2. The fact that we have symmetric bounds makes us, the first thing you want to think of is, could we do something with even and odd functions to make the problem easier? And that we can actually do. So first what we want to do before we check that is we want to distribute this square root of 4 minus x squared into both of our terms here. So our integral will turn into the integral from -2 to 2 of the square root 4 minus x squared multiplied by x cubed cosine of x over 2. And to that we will add 1/2 of that same square root from earlier. At this point what we would do is we would just split up the integrals, so I'm just going to split it up kind of crudely there, whatever, but now the integrals are two different integrals, and we can actually check for even odd function stuff. So we're going to check this first one up here. Square root of 4 minus x squared multiplied by x cubed multiplied by cosine of x over 2. Now 4 minus x squared, that is under the square root, and that's always going to be even, especially because we have an x squared under the square root. So that's, if we went through the check of even versus odd functions the long way, that would be an even function. So this first part, that square root's an even function. And we know that cosine is going to be an even function, so that one's just easy. The only other one we might check is x cubed, and let's just go through the long way to check that. So we remember that if to detect even versus odd function, you see if f of x, or f of negative x, equals negative f of x. That would give you an odd function. So in this case, we are using x cubed, so we want to see if negative x cubed equals of negative x cubed. There's parentheses here. I can't exactly say it differently, but this is how it's different visually. Basically, like this is how to show it differently. Yeah. So I'm just going to plug in a number. I'm going to plug in 1. So this will essentially be negative of 1 cubed, and see if that equals the negative 1 all cubed. So on the left side, 1 cubed is just 1. We have a negative, so it's negative. So that's negative 1. And then negative 1 all cubed, that's negative 1 times negative 1 times negative 1. And that equals negative 1. So because we actually proved that f of negative x equals negative f of x in this case, that means that this one small part in this whole integral is an odd function. And an odd function times even function just makes the whole thing still an odd function. And because we have symmetric bounds, this whole integral just goes to 0. All goes bye-bye. We don't have to think about it. So that first integral is gone now, and we just have to worry about the second integral. And this second integral is the integral from -2 to 2 of 1/2 square root of 4 minus x squared. Now we determined earlier that this square root is even, and the 1/2 is not going to change that. However, this is actually a really easy integral. It's not exactly easy to see if you're new to integration. However, the square root of 4 minus x squared is actually just a semicircle in this, and it's from -2 to 2. And in this case, I say -2 to 2 because of the bounds, but that's actually how the whole semicircle is set up. And the way a semicircle is written is we have the square root of radius squared minus x squared. And so radius squared in this case is 4, therefore our radius is 2. And that means that the semicircle is actually just the full length of our bounds. So all we have to do in this case is we just have to find the area of this semicircle, because integration is just area. And then we have to divide it by 2 because there's 1/2 out front. So remember, our formula for a semicircle is going to be pi r squared over 2. And because we have this 1/2 out here, we're going to multiply this by 1/2. So if we simplify this, this will be pi r squared over 4 for our specific case. And then now all we have to do is plug in our radius. Our radius, we said, was 2. So this is going to equal pi times 2 squared over 2. That's going to, or over 4. My bad. And then so if we simplify that, that will just be 4 pi over 4. The 4's cancel. And our final answer is just pi. Now, if I put that actual problem back on the screen, the actual meme picture, whatever, I believe it said we want the first 10 digits of the answer. So we're just going to do the first 10 digits of pi, which would be 3.141592653. Is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. 314159265 So if you're looking for the answer to the integral, it's pi. If you're looking for the answer to the meme, it's going to be the first 10 digits of pi. So it started off looking really ugly, but it actually got a beautiful solution.